Now, the next we'll be dealing with is on use of small angle approximation, and you have the radian. We have differentiation of trigonometrical and algebraic functions, and we will have about the integration of trigonometric and algebraic functions. But you have to take your Bible now and write. Ready? When I come back, just take your Bible and write. Take your books. Take your paper. Now, are you set now? Take your Bible and let's write. Now, let's go. 1. Use of small angle approximations. Because all these things you need to write them down as we continue for further analysis and kind of application of some of these functions to get our solutions. Okay? Now, use of small angle approximations. These are functions. These are formula 1. You have sin theta is equal to tan theta. Maybe some of you who are students of physics, you are used to this already, but for the sake of this level, we have to go into these basics. These are basic mathematical functions you need to know as related to physics that you need to know. Okay. Now, use of small angle approximations. You have sin theta is equal to tan theta, which is equal to theta, and cos theta is equal to 1 for small theta. Now, next, you have radian measurements. Radian measurements. You have tan radian is equal to length of arc of a circle all over the radius. Now, then you have differentiation or differentiation of trigonometrical and algebraic functions. You have d all over dx, bracket open, sin nx, bracket close is equal to n cos nx. Write it down. Now, the next one is d all over dx, bracket open, cos nx, bracket close is equal to minus n sin nx. You have to write all these ones down. These are functions. Then the next one is d all over dx, bracket open, tan nx, bracket close is equal to ns square nx. Now the next one is d all over dx, bracket open, x raised to power 1. No, rather. Raised to power, yes, raised to power 1, bracket close, is equal to nx, n minus nx, raised to power n minus 1. Now the next one is d all over dx, bracket close, or bracket open, ex, e raised to power x, bracket close, will be equal to e raised to power x. Then you have d all over dx, bracket open, a raised to power x, bracket close, is equal to ax, a raised to power x, l n a. Okay? N is just signify is this the unit. The unit is the unit. As we go, that's what that n. Anyway, you see n, so we'll continue. Now, the next one is d all over dx, bracket close, uv bracket open, uv bracket close, which is equal to v dx v du all over dx minus u dv all over dx. The next one is d all over dx, bracket open, u all over v, bracket close is equal to v du all over dx minus u dv all over dx all over v squared. Now, d bracket dx, that's the next one. D bracket dx, bracket open, ln x, bracket close is equal to 1 all over x. Now, let's go to the integration. The integration of trigonometrical and algebraic functions. How do you integrate them together? Now, give us sin nx, so dx is equal to minus 1 all over n, cos nx. Then the next one is cos n times dx is equal to 1 over n sin nx. The other one is tan n nx that x dx is equal to 1 over n ln, which is s, which is, therefore it will give you sec, that's in seconds, okay? That is nx. The next one is x raised to power n dx is equal to x raised to power n plus 1 over n plus 1 bracket open n equals to minus 1 bracket close. Another one is 1 over x dx is equal to 1 nx, while the other one is e raised to power x dx is equal to e raised to power x. Those are the integration, how we integrate those functions. Now another one is 1 over 2 1 over x squared plus a squared dx is equal to 1 over, which is equal to now 1 over a tan minus 1 tan raised to power 1 minus 1, that will be bracket x bracket open x bracket close all over a. The next one is 1 over x squared minus a x squared, that's 1 over x squared minus a squared dx is equal to 1 over 2a I n bracket open x minus a bracket all over bracket open x plus a bracket x greater than a. These are integration and these are the functions. We will continue to apply them, working them out. So you have to have all this. So write them out. If you've missed out on anyone, go back to the video, write them down, all those functions. The ones I've given you already, go back and have them by your hand. We are going to deal with them one by one. Of course, do not forget, we are dealing on vibration waves. Vibration waves, okay? These are geometric on itself, okay? We are dealing on the vibration precisely. Most of these things will be dealing on vibrations, dealing on waves, about waves, whether sound waves or any other waves for that matter. We'll be dealing on that. So these are formulas that are guiding them that we shall be dealing with, okay? Thank you very much. Keep inviting friends to fix this, okay? Because of my tight schedule, we are taking our time so that we'll be taking them one out of the other. Fixes is not something you rush. It's just like math. So we'll be dealing with one after the other. This is a class that we'll be talking heart on heart, heart to heart, okay? Thank you very much. Invite friends, subscribe, and view. In fact, I need your view to meet some targets. That's another thing. So view, look for some courses, look for some subjects, look for some topics that interest you, comment, and we work together. Thank you.